No, no, Shreen. Okay. Now, this is this chapter is two for the t-test for two independent samples. Now, the first question in the assignment tells you that you have a test for null hypothesis. You have an old method to do something versus new method to do something. So you have two groups. And you want to see if they're different. And the question, does the confidence interval contain the number 0? Okay, this is just a basic idea of the idea of containing 0, not containing 0. I'll tell you how this is done. First of all, if you do it as hypothesis, you have H0, HA. H0, you'll say mu of group 1, which is old, not equal group 2. No, this one you say they're equal, and here you say they're not equal. So here you're saying that they're different, and here you're saying that they're the same. But we don't like saying the same, we say not different. So hey, here we say different, here we say not different. Now, in general, if your p-value is less than or equal alpha, you're going to reject H0 and conclude HA. P-value more than alpha, you're going not to reject H0, not conclude HA. So basically what we say here, in the first one, that HA is true. And in this one, what we're saying is H0 is true. So going back to the actual question, in the question they tell you that assume that your p-value is 0.095 and alpha is 5%. So they tell you p-value is 0.95. They tell you alpha is 5%. 9 is more than 5, so your p-value is more. So you're not rejecting H0, you're not concluding HA, H0 is true. Meaning that they're not different. So that's what we have using hypothesis analysis. We know that the two groups are not different. Now we go back to the question. Remember, they're not different. Now the question is, does your confidence interval contain the number 0? When you do confidence interval for two groups, you will end up with 3 possible scenarios when you do confidence interval for two groups. It could be that the first number is negative, the second number is negative. It could be that the first number is positive, the second number is positive. It could be that the first number is negative and the second number is positive. Negative, negative means they are different since 0 is not within confidence interval. When you have negative between two negative numbers, you're not going through the 0. 0 is not between two negative numbers. In this case, the groups are different. 0 is not within. When you're between two positive numbers, again, no 0. Difference since 0 is not within confidence interval. But when you're between negative positive, that's the only time you're not different, meaning that it could be the same, since 0 is within confidence interval. So the answer is, well, we know it's not different. Would it contain 0? Of course, yes, it would contain 0, since we proved using the hypothesis that they are not different. Okay, so that's the basic idea of how to handle hypothesis confidence interval for two-sample independent. Now the second question is again comparing two different groups, comparing grades on the final exam for people learning or taking the course distance and the people taking it on campus. In the Minitab, they told you they have 12 students here. This is your sample size N. 12 students taking the course distance and 12 taking campus. The average in the final exam here was 66.17, and the average here was 86. Standard deviation for this one is 4.91, and for this one is 11. And they tell you that 95% confidence interval was between the two numbers negative 2185 and negative 698. Question is, interpret this interval in English. And they tell you, assume that all the assumptions are met. The way we interpret the confidence interval, first of all, since they mentioned the assumptions met, so we say since assumptions hold, and this is 95, so we say we are 95% confident that the population, that the difference, because this one is difference between the population mean of and I'm going to use a different color of final exam grade for all students taking the course distance and all students taking the course on campus is between negative 2185, negative 69598. Okay. Now there are a few things I want to comment on. Now anything in blue, that's the only thing you change. Everything else is the same. So, well, it depends if it's 95 or 90%. So you also change this according to whatever given. So you said that the assumptions hold with 95% difference between population mean of, and you say what the mean is. And in the question, they tell you this is the mean age of students, this is the mean height. In this case, it's the mean in the question of the final exam grade. And then you say for all, and you mention what the first group is. The first group is students taking the course distance. And you mentioned the other group, all students taking the course campus is between, and you put the two numbers. The other thing, this is the standard they do in the class every year. I don't know if Nelson changed this a little bit. I looked at the notes that they provided. They don't give you enough information, so I'm hoping that he's using the same structure that all the other profs are using. This is the standard way. So hopefully he uses the same thing. Now the other thing is, he might ask you in the exam to calculate this. So I'm going to calculate this. Now, the confidence interval for the two sample, I should say two sample, I said that. It's a two independent sample because there is the two dependent, that's the next chapter. Now, to calculate this, the formula that we use is average of group 1 minus average of group 2 plus or minus T star square root standard deviation 1 squared over n1 standard deviation squared over n2. The averages we have, the standard deviations we have, only T star we need. We get this from the T table. You need degrees of freedom. Okay, there's a big story about the degree freedom only for this case. We're going, now in the exam, you can't really do the degree freedom exactly, so you're going to approximate it. Unless it's given in Minitab. So in this question, it wasn't given in Minitab. So Minitab using the accurate degree of freedom, but in the exam, if you're not given the degree of freedom, use the approximate, and the approximate would be n1 plus n2 minus 2, so it would be 12 plus 12 minus 2, and that would give you 22, and it's 95. So our calculation is not going to be exactly like this. It will be a little bit off, but acceptable, because you don't have there's no way to calculate the accurate degree of freedom, so you can only estimate it if you have to do this in the exam. Again, you're not asked to do the calculation here, but I'm just doing it so that you're familiar with it. You go to the T table, any T table, the one you use for the course, You go to the degree freedom 22, you see all kinds of numbers. With confidence interval 95%, the common number between them is 2.074, which is not what Minitab is using. Minitab is using a number that's very close to this. Average group 1 at 66.17, average group 2 is 80.6. Plus or minus T star, the approximate number. Then the first standard deviation squared over 12, and the second standard deviation squared over 12. I'm going to maybe delete some of this. Okay. So you do the first part. What is 66.17 minus 80.6? This number is minus this will give you negative 1443. And you do all of this, from the number 2 all the way to the end, 2074 times square root 491 squared over 12, 11 squared over 12. This number is 72121. Then you open brackets, you minus the two numbers, you add the two numbers. So you go this minus this, this plus this. So negative 1443 minus 72121 takes you down to 216421, and if you add them, it takes you to 72179. Now, you'll see it's not exact. This one is off by about 0.15, and this one as well. So this is approximation, because Minitab uses the correct way. So, but in the exam, if you're asked to do it this way, because you don't have the accurate degree of freedom, and this one mathematically acceptable. Okay, so we go to the next one, question 3. It's referring to the same question. Are the two groups different? So the distance and the on-campus different or not? So distance and on-campus, are they different or not, according to the confidence interval? The confidence interval, when we calculate, or the one given in Minitab, was between these two numbers. So does this mean that they're different or not? Remember, at the beginning of this video, I told you when you do confidence interval for two groups, negative, negative, could be positive, positive, negative, positive. This one is different, this one is different, this one is not. These two, since 0, not within. And this one, not different since 0 is within. So in our case, are the two groups different? Yeah, definitely. They're different because they're negative, negative, 0 is not within. So your answer is yes. The two groups are different since 0, not within confidence interval. Okay. The next question, they tell you about two groups of decoders. So you have decoders decoding messages. So they have two systems to this is military question, so they have two different systems to decode messages, and they tell you that they have sample 1, 2, device 1, device 2. They tested the first one on 24 messages and the second one on 25 messages. They give you the mean time in minutes. How long does it take to decode a message? That's all given in Minitab. You're also given the standard deviation. You're also given SE, standard error, but we don't use that, so don't worry about it. And you're also given 95% confidence interval, and it's between two positive numbers. And the question is, can you assess the assumptions? Now, the assumptions for this chapter, the first assumption is called the independence assumption. In the actual question, when they tell you that they have a certain number of messages, these messages or this sample must be selected randomly. So if you go back to the question and start of paragraph 2, two special agents randomly assign 49 randomly selected messages to two groups. So when you see this, then this condition is met. They are, or the groups are independent since the sample of messages selected randomly. Good? This is the first assumption. Assumption number 2, so the first assumption is met. Assumption number 2 is called normal population assumption. Now, in order to check this assumptions, you have one of two choices. They either tell you in the question that it's normal distribution, and if they mention this in the question, we're fine, you don't need to do anything. So they either mention it in the question, or they give you the histogram, or the normal plot. So they're not they haven't mentioned in the question the fact that it's normal distribution. They haven't mentioned in the question that it's normal distribution, and there is no plot given. So in this case, you say cannot assess, no histogram, or normal probability plot given. In this case, since you don't have a normal probability given, then you have to mention that, therefore, sample size assumption must be checked. So, for example, if they tell you that you have normal distribution, or if the histogram given and it looks perfect, like this, like normal distribution, then you're okay. You don't have to do the sample size assumption. But since we don't have the histogram, or we don't have they don't mention this in the question, then you have to check sample size. So now sample size assumption. You will see this in the notes for this chapter for Module 1 and also for Module 2. They give you a structure. For n less than 15, you have to mention something. If you're between 15 and 40, you have to say something. And if it's n more than 40, you have to mention something. So for example, here, both samples, or the samples in the question are 24 and 25, both in the range 15 to 40. If you're in this second range, some skewing is okay. If you're more than 40, assumption met. It doesn't matter. Data could be highly skewed and you're still okay. So if you're more than this, you're okay, assumption met. If you're between 15 and 40, you can allow for some skewing only. And if you're less than 15, then it has to be normal. It has to be perfect. So you allow for some skewing. Some skewing is okay. But again, we don't know. The question doesn't mention whether you're a little bit skewed or not, so we don't know. Cannot assess. So you can't really say here that the assumption is met, and you can't say that it's not met. You can only mention that, well, we can't really do anything at this point because we need more information. So you just leave it as that. The last assumption for this chapter, the independent groups. And this is standard. All you need to say the two groups are independent. And that's always the case. Again, I'm answering this question, the assumptions and all of this, from the standard of the course. I don't know I don't think Nelson would have a different way of doing this, but they have the tendency of changing the wording a little bit, but I give you the standard way, and I think that's the standard that they've been doing lately. Okay, so this is the end of this question. The next one. So we verify the assumptions. They also tell you in Minitab, they have something in Minitab called t-test 355 and p-value 001. Now, they tell you in the next one, I erased this for no reason. So 3102, 368. So they give you the p-value. In the next part, they only want you to, from Minitab, what's the t-test, what's the p-value. So you just put them down. The t-test is 355001. But before I go to the next question, I want to talk about this a little bit. How is this number actually calculated? I showed you how to calculate the confidence interval approximately because you need the degree of freedom. This one we have to get exact. The formula to calculate this is average group 1, average group 2, over standard deviation 1 squared, standard deviation 2 squared. So I take my calculator, fraction, average group 1, 37.48, minus average group 2, 31.02. In the bottom, I need a square root. Standard deviation 1 is 816, I square it, and I divide by the sample size 24. And then I need the 368, I square it, and I divide by the sample 25. You do this in the calculator and you get 254747, and if you round it to 2 decimal places, you get the same answer, 355. So this one, you must get the same answer because the formula doesn't have a degree freedom. And yeah, they might ask you to calculate it yourself, and that's the formula we use, but everything else will be given. Now, for the next part, yeah, they want you to state the hypothesis and define the parameters for this one. And the hypothesis testing for difference. Are the two groups different? Okay. Hypothesis for difference. In H0, you say group 1 equals group 2. Sometimes they say mu1 minus mu2 equals 0. And here they're not equal. Sometimes they say this. To define mu1, you say let mu1 be population mean of, and whatever the mean given in the question, it's time needed to, in minutes, because it has a unit measurements, time needed in minutes to decode all messages, because your decode a sample as messages, all messages by group 1. And group 1, the name of group 1 was given in the question. It's a kind of a device for decoding. It's called Deciphermatic. So this is how you define mu1. Everything in blue is standard, but the mean, you take it from the question what the mean is, and if there is a unit measurement, you say, you have to say in minutes, seconds, hours, whatever, and what the sample is, and what the name of the group is. To define mu2, you see, it's the same thing. Mu2, population mean, time needed to do decode for all messages by, but now you mention the name of the other. And the name of the other group is quick decipher. Okay. They want you after this to assess strength. But remember, H0 was mu1 minus mu2, 0. This means not different. And HA was mu1 minus mu2, not equal 0, and this means different. To assess strength, I couldn't find this in your notes, but there is a section. There is a section for strength. You see your p-value is 0.01. This section, if you can find it, and you're probably familiar with it, they tell you if your p-value more than 10%, you say something. If you're between 10 and 5, you say something. If your p-value between 5 and 1%, you say something. And if it's less than 1%, you say something. Your p-value would be in the last range. It's less than 0.1. Again, this is the standard for the strings unless they change, but they haven't changed this in quite some time. So your p-value less than 0.1, so you say very strong evidence. So very small p-value, very small p-value, very strong evidence to support HA. So this is, you'll see, I mean, you just need to say whatever that comes with it. So p-value is less, very strong evidence to support HA. Now in the last step, you need to talk about the conclusion of the question. Are they different or not different? Now, remember how I wrote, I want you to just go back and look at the one where I wrote the previous conclusion, because this one is different. This one, no alpha given. You don't have alpha. So you have to base the conclusion on strengths. Meaning, first of all, when we discussed the assumptions, we couldn't confirm that the assumptions are met. So we don't say since assumptions met. We say if assumptions hold, and you have to say, according to the strengths, we have, this is according to the strengths, we have strong evidence to support HA. Because that's what we saw, that's what we said in strength. But you don't say HA, you say what HA is. So we have strong evidence to support HA that the two groups of decoders are different in the population mean time in minutes needed to decode messages. Good? So this is what you say. I mean, the questions are, before I talk about this, there is, this is all the questions in the assignment. One other thing that they can ask you, and there was no question in the, there was nothing in the assignments about it, but you might see it, is can we pool the information, the groups? Now the structure for pooling, pool, or they could say, do they have equal variances? The standard is you take the S large squared over S small squared, and if this happens to be more than 2, then yes, they have equal variances. Can pool. if you take S large squared S small squared, if it's less than 2, no, don't have equal variances, can pull, cannot pull. I know for a fact that they could change this sometimes and make it just S large over S small without squaring. I'll have to look into the notes to see if there are two different approaches. The standard is to take the S large squared over S small squared. Or to take, but the concept is still the same. So if you follow this, S large would be, the larger one is 816 u squared, and the smaller one is 368 u squared. This gives you about 492, that's more, way more than 2. So you say, yes, they have equal variances, can pull. In some instances, they could just take the numbers without squaring. So it'd be the 8, just the 8 over 3, no squaring. But you still get, like, even if you don't square, you get 2.22, that's more than 2. So it usually doesn't matter. I'll double check which approach he's using this here. I'll let you know later. But again, we'll follow this. We'll see what your mark is for this assignment. Hopefully, if you get a very good mark, then they're following the same standards that they usually follow every year for the course, and it will be good to go. So hopefully that will be okay. This is all you need to do, or all you need to know for the assignment. Good luck.